argue the central limit theorem and that 10% rule first. So CLT, how many are in our randomly selected 10 young women? We don't get to argue with the central limit theorem on this one because there aren't 30. But we can argue
It's definitely not at least 10%.
in the 10% rule because there are at least
Wait,
10 women.
Wait, I thought it had to be at least 10%.
Yeah.
So that's nowhere near 10%.
No, there are at least 10 women who are taller than 66.5 inches. So our sample was 10 on part B at least. Part A was just the one person. I don't really feel like you even have to argue with the one person. Right?
Yeah, but I thought it had to be greater than 10%.
Yeah, so we're saying that our population is greater than 10%, or greater than this sample of 10.
So then we can not normal? Because it's not at least 10%. Maybe I'm using words wrong.
Yeah, there are at least 10 women taller than 66.5 inches. Okay, so back to our notes. Oh, and I say words again, Kenzie.
I said I think that the rule is it cannot exceed 10%.
Yes. Yes.
You thought it had to be 10%?
No, not on the notes. Sorry. Oh, yes. Yes. Thank you. God bless you. And I have to figure out what he wanted. Good. Perfect. Even better. Okay, I don't want to do number 2 because you're smart. Oh, maybe I do want to do number 2. Why would I want to do number 2?
Sample or proportion one?
It's a proportion one. We need to practice the proportion one. So here, you and your people can try number 2.
Oh, square root of p times 1 minus p over n. Oh, crap, no.
I did a better job of actually checking the conditions on number 2, Kenzie. Which is what I was supposed to do. Oh, I did the NP and the N1 minus P.
0.8 times 0.0.
Okay, so it would be 25 divided by 0.2. And that's
It's a proportions problem, so you gotta use the other formula.
yeah, we did.
I'm not talking to you. Yeah, I already heard your number. I got the same number.
That doesn't make sense.
So you got the 0.04.
0.04.
0.04 was the standard deviation. You have to do a z-score, so that's the denominator when you make
So
so.
25 divided by 0.04.
You do your mean minus the expected over 0.04.
You're right.
Did I do an inverse?
Oh, like 100 minus 75 it's encompassed to the students.
Can I do an inverse normal of that?
You could.
0.0.
It'd be fancy.
0.05 divided by 0.04.
Again, I'm not fancy. I'm old school, so I did a z table and I just looked at the negative numbers on my z table. That's what I got. -1.85.
So lower bound would be guess big negative number. That makes sense. You know what I mean? Like, roll down there, and then 1.25.
Lower bound would be negative, lots of letters.
Yeah.
Upper would be what?
Or 1 to the front. And then mean is 0, then deviation is 1.
Negative 1.25.
Dang it, negative 1.25. No.
You know,
0.11. So 11%. Is that what you got?
yeah, but you know, Hunter, you haven't liked transferring it to z-scores lately, so you can still do lower negative 1,000 or whatever, a bunch of zeros, the upper of 0.75, the mean of 0.80, the standard deviation that was given, or that you calculated the
Try to solve
0.04.
time.
You don't have to.
Okay, so it's like,
You don't have to do the z-score way if you don't want to.
okay, because I didn't really look at it. So when it says X percent of people is doing this thing, that's what I should assume the mean is.
Yeah.
Okay. That would cool.
I mean,
So you still would have had to calculate the standard deviation of the 0.04, but you could have used the given mean of the 0.8 and the lower,
Lower would have been one bunch of zeros.
and the upper is 0.75, yeah. Yeah, like that.
Okay.
So they got the same.
Yeah, I did.
Yeah. No, I'm just talking to Hunter about how he normally likes things. He normally doesn't like to convert to z-scores.
It doesn't change how much, so then we should 0.042. So it's
That's about it.
yeah, I would say probably not. Oh, dang. Probably. Probably not.
Well, it's just weird to say it's usual. So it makes more sense than it's not unusual.
It's probably not unusual as the difference between
It's super
original
unusual.
population, original sample and secondary sample.
Well, I'm trying to use the exact same phrasing as with the unusual.
No. So if it says exactly 90, is that going to
I did 90 or higher. Yes. What number did you get on Part B? Yeah. What, tell me what number. Yeah, for the Z, yeah. So you got, yeah, so you got like basically 0. It's like 0.0062. Yeah, same. And they said that's usual. Is that usual? Is it a small percentage? They said at the beginning of the problem, 80% taking it are female. And the odds that we have a class of 100, 90 of them are female, and you got a super low percentage. So I think, yeah. Yeah, I think, but we got, the percentage of that happening is basically 0. to get that low of a percentage. Isn't that unusual? Yeah.
English kid who went to school
Okay, let's talk about this one. I think we agree on our numbers. I just think we disagree on our logic. Okay, I checked the NP and the N times 1 minus P first in order to say that it was normal and to do my normal Z stuff. I converted to a Z-score. Well, I had to get the standard deviation of 0.04. But I converted to a Z-score, and I end up getting a percentage of basically 11%. I think we're all on the same page on A. I will gladly post this key later if you would like to look at it. I will gladly. Okay, so I think we all agree on A. The issue is on B with the words. So on B, if we read the problem again, it said, what did I do with it? It said, okay, so yeah, so on part B, they tell you about, that it used to be a sample of, we had a sample of 100, and what if out of the 100, 90% of them were female? So, or 90 of the 100 were female, which is 90%. So I still converted to a Z-scoring at 2.5. I still did, how much is bigger than 90, and I got such a tiny percentage here. And Kenzie and I agree on this tiny percentage, and I swear group 1 does too, but then we disagree with our words.
No, group 1 goes.
Okay.
I can't even read. Now I can read.
Okay, because in an aerobics class, it's common for it to be mostly girls. We would not be surprised if it was a class and no boys were there that day. So when we said that 90%, so there were 10 guys in the room, and we got basically a 0% chance of that happening, that does not seem that rare. I've been to a lot of classes that don't have boys.
Okay, so it's fair to say that, as long as we said it's most likely not. Oh, never mind. I was stupid.
Since we got such a low percentage, we got less than 1%, we got a low percentage going on.
Yeah.
Less than 1%. That is unusual.
Yeah.
Because we expect mostly girls in an aerobics class. So your math was right, but your words were wrong, so at best you get the P.
So you want us to keep our answer in IP?
No. I just wanted to discuss how we would grade it.
You want to remember our failure.
Yeah, I know, you don't have to remember your failure. You can fix it and correct it.
So this isn't our.
But no. This one is not our exact frapping.
I got so excited.
This is too easy to be a frappy.
This is not our frapping. I forgot what our frapping dealt with. It's not aerobics class.
Exactly.
Messed it up. Well, there's 2 sets of free responses on this.
Neither are actually straight from the test. Sorry, Mary Doll.
Yeah, that's just tough choice.
I know that would make your day, but sorry. That is not what happened.
Well, you said that our frappies in our hands, I got confused.
No, I don't know.
She goes here.
Wait, what is it?
The exercise class.
Oh, I should have known that. I'm a lifeguard. They show up all the time.
Kind of
For
like,
some reason I
So
thought we were
stupid.
talking about
I'm sorry, unless you understand.
in my mind, I went straight to Zumba, yoga, all the girly classes that boys are never in.
And they're almost never under the
Step class. I thought aerobics was anything that got your heart active. I don't know. I'm not a physical education teacher. Not
That's
always.
aerobics.
I'm sure that there's some boys and other ones, but not so much in Zumba. So maybe that was.
In my mind, I was thinking Zumba class. I see Zumba class going to
Yeah.
dancing,
When
and
it
no
comes
boys
to
in there.
water aerobics, it's almost always women between 60 and 80.
They also only offer the class at 8 o'clock in the morning, so there's a reason there's that age group. But I digress, because I thought it sounded fun, but I didn't like the time it started. Okay,
Another follow.
on number 3, let's skip that one. Why are we skipping 3? We just did proportions. Hearing trouble is actually very common, so that would be a good one to do. Let's do number 4. I like the way it's worded.
Average weight of giraffes.
Oh, I'm very quickly deteriorating.
Okay, so this is a
means. Yes, dear.
Oh.
I don't know if you do it.
I still have work shown on my paper, yeah.
Oh my goodness.
I mean,
I just looked
yeah.
at the board to remember that I'm taking the ACT in like 2 weeks.
I have like open up my eyes just to get the big factor there.
Take the ACT. It's not bad with the seniors. So that's the point if they want to go to college.
That's a move. My brain has stopped working.
But the catch is he has a filter.
No, no, kind of like this. Makes class enjoyable.
There's our teacher suicidal.
That's a move. I shared that honestly. It's just something.
How you doing, Miss Compton?
Okay.
Better now?
On the standard deviation, I don't get that much.
What did you get for standard deviation?
42.43. So, okay, so obviously Anna's supposed to find it. You asked me for it and you found it, so I don't know what to do with it.
Still go to a Z-score. Still give me a percentage.
Wait,
Still, it's the same thing every single problem.
what do you mean? Okay, fine. 200 divided by that number, I guess. 2,600 minus 800. Because it's a sample mean. It is a sample, so define the standard deviation of the sample.
He was just skipping steps. Instead of putting 2,600 minus 2,400, he went straight to the 200 difference.
I don't know if he's scored chart. Yes. Oh,
Do we have to do 1 minus?
you will make logic.
It said in the problem, so you would want to know 2,600 or greater. So would you would minus?
Yeah.
I didn't. Yeah. Sorry, I'm slow. I understand what you're asking now, Kenzie.
You find the same thing, right? 4.1.
Wait, Jackson, you're missing something crucial. You don't have the laces on your hood.
So then, no, because it doesn't even go that far.
I don't know why, but I mean,
Yeah, I don't think so. Maybe, no, I have no idea.
It's a big percent. Did you do 1 minus?
I'm gonna say,
Double figure.
yeah, the sample mean has to be the same. I mean, yeah, but I'm not sure.
What are you doing,
I think
Caleb?
I asked for something else the other day, and I have no idea. You just stopped.
Oh. You're welcome.
I just got a number.
It only takes 3 pounds of force to rip it out, Jack.
Oh, I understand your problem because it didn't go to 4 whatever on here. How'd you do 4.71?
Yeah, we got that. We was-
What'd you get for your Z score?
I got 0.6.
For your Z score? What'd you do? What'd you get for the standard deviation?
She must have divided 4.2 divided by 200.
Ignore him. What did you get for your standard deviation?
Sorry.
He's like skipping things.
I did minus 0.7454.
Jackson.
Where did you get the 0.745 for? How'd you get a z-score 0.66? Divided by what? Why are you dividing by 300? Did you use the means, on the formula sheet, weren't you supposed to do the standard deviation divided by the square root of n? Did you divide by the square root of n? So have you actually used the correct standard deviation? No. So you need to have divided by square root of 50, yeah. Okay, let's talk about this one. The reason we did this one is because since our sample size was how many? So that's bigger than
30.
So by the central limit theorem, we can go ahead and assume our family distribution is normal. So don't forget, we have to convert to get the standard deviation we need. So you take what they gave you and divide by the square root of n. And so 2600 minus 2400, 42.43. I converted that to a z-score, got 4.71, which I don't know if you looked at your z-table lately, but it doesn't go that far. So finally, I had to cave and use my calculator. Although, I'm not even going to lie, I pulled a Jackson, not a Jackson, I pulled a Hunter. Straight up Hunter. Straight up Hunter.
Yay!
I pulled a straight up Hunter and didn't even use my z-scores. I used the stuff given in the problem. Although if I wanted to, I could have used my z-scores, but I was just proving a point to myself.
That's kind of a low upper for having such big numbers, though.
But, yeah. So true. I should type in some more zeros. Can't hurt. Okay, but regardless, I get something e to the negative 6, which means I got to move my decimal over that many times, which means this is basically as close to 0 as we're getting. Hence why on my paper I literally just put 0. Is it? What did the problem ask? It said, is our data consistent with what we've been told? We found that 0% of a chance that our elephants weigh 2,600 or more pounds. And yet we were giraffes. Elephants, giraffes. Thank you, Kenzie. We've been told, on average, that the giraffe weighs 2,400 pounds. Yet we found that no giraffes weigh more than 2,600 pounds. So, no. The mean is probably not 2,400. If so, there would be some, I mean, that's only a 200-pound difference, and we're saying there aren't any that weigh 200-plus pounds? My gosh. So, no, the mean is probably not 2,400 pounds for the giraffes. Okay, number 5. I don't know.
So are these words? Okay. I say no because there's a 0% chance that a mean of 50 giraffes is 2,600.
Yes, I'm good with that.
But I was saying no because never mind.
No, because of what?
Because in the book it said like the sampling. Is this for this one? If the sampling equals
Well, our sample mean was 2,600 and our mean was 2,400, so they didn't match, though.
right, that's why I said no, it's not consistent.
Because they didn't match.
Yes, but I don't know if that's like.
Yeah, I would argue that. It's still got to do with the fact that they said 2,400 is normal. Yet when we tried to see how many giraffes weigh more than that, we found out none do. So shouldn't we have, if this was really a normal thing, shouldn't we have a couple down here? Yeah, we have none. So really our stuff, our mean is probably down towards this end with a different curve drawn this way. It's probably like this at like 2,000. That's why there's no 2,600s, because that's so close to the very end of the tail.
But if you took like a population that does weigh 20 or whatever it
2,400.
weighs,
Yeah.
weigh 2,400 and then
Right.
sample it. If they don't match, then that's not.
Well, see, we're doing, yeah, they should match, like you're saying, because we're doing multiple. We didn't just do one sample, we did 50.
So even if you did do that match, you know it didn't match because, I mean, you know it wasn't consistent because
You would have thought they would have been closer together. Yeah,
Yeah.
that's true. But I mean, but close together, is 200 pounds that big of a difference with giraffes? I don't know.
What I would do then.
Yeah, that's true. That's true. 200 pounds that big of a difference with giraffes? I don't know. Okay, that's a good question. That's what I would think. Again, that too. I don't know the average weight of a giraffe as to whether or not this was all ridiculous to begin with. Okay, I don't want to do number 6, but I want someone to tell me the important words in number 6 that you should notice. Oh my gosh, yes. So in number 6, the population is normal, so we can automatically assume the sampling distribution is going to be normal as well. So we can go ahead and do all our normal stuff. I'm not going to make you do it, but we can. Okay, let's read through some of the multiple choice before we run out of time. Number 4. Perfect. Okay, Shalia wants to go to number 4. Sounds good to me. I flip a coin 10 times and record the proportions of heads I obtain. And then repeat the process of flipping the 10 coins at the 10 times and record the proportion of heads obtained many, many times. When done, I make a histogram of my results. The histogram approximates what?
E, right?
You know that the more times you flip a coin, the closer and closer.
It gets to 50-50.
Yeah.
As it should. Yeah.
Well, I had to do ingenuity on probability for a long time for ACT Pro.
Yeah. Okay, but so we found a sample and then we repeated it many, many times. So we took multiple samples, and multiple samples are called a sampling. So the only option could be, Louise is correct, it's D.
Wow.
Okay, let's see, number 5. The variability of a statistic is described by blank. Yeah, 5 is A. The variability is describing the spread of its sampling distribution. So 5 is A.
So is this the chapter where we cuss, or was that last one?
We could still cuss with the sampling distribution if we wanted to, but we're normally just trying to say it's normal, to go to a Z-score, to have a percentage, to say something about the population as a whole.
Is one,
One is E.
what's two?
One's E, two's A. Mm-hmm. Shalia had her weenies.
Did you say Shalia had her weenies?
Mm-hmm.
Makes sense. Julia had no knees. I was like, what?
I thought you said you had
When I was
no
little. my
Okay,
parents-
let's do 3. I like 3. Which of the following is correct?
A.
What? Keep reading. Well,
Never mind.
E.
Dude, C.
it was A. My gosh.
Oh, it was A.
Dang it.
Ugh.
It says
There's more than just
Parameters go with population. Parameters go with population. Statistics go with sample. Yeah.
There's more than just a simple
No.
sample, guys.
It doesn't have to be a simple random sample. There are other ways to sample.
Yeah.
Okay. 6. Did we do 4? We did 4. 1, 2, 3, 4. We did 5. She wants 6. Okay, 6. Do you have a guess already, ma'am?
No.
Okay, 6. If we took a simple random sample of 1,700 people from California, and a simple random sample of 1,000 people from Detroit, which sampling distribution would have the smaller standard deviation? This is what Jackson was asking me about yesterday. Finally, I know what he was talking about. Yay.
As the standard, or as the population increases, the population increases? Correct.
Well, as our sample increases, our standard deviation does decrease, but it matters that the populations are of different sizes. So even though California has a bigger sample of the 1,700, it had such a larger population. Is that bigger sample really proportional to the samples taken from Detroit with only 1 million people?
No.
So the answer should be
It's not A.
D.
I would have thought A.
Right?
I would have thought A. I would have given my life's blood for A.
So it's not A.
but it's not A. Sadly, apparently, I am wrong because I guess I'm overthinking it, even though I'm telling you would think proportional wise.
Favorite speed.
So the answer, sadly enough, according to my old school cue, which I don't know, maybe it's wrong, literally what Jackson wanted all along, of the larger the sample size, the smaller the standard deviation. Like, I'm overthinking it by considering the population at all.
Wait,
So
C?
it's seriously C, because it's a bigger sample, it's better.
Can I retire from school?
Yeah, sadly enough. So Miss Compton overthought life, literally because 1,700 is bigger than 1,000, regardless of the populations they're from. Because 1,700 is bigger than 1,000, 1,700 is better. Okay, 7. Shalia wants to know the answer to 7. 7 is A. It is supposed to be the mean blah, 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 P. Is it mu and then a mu P hat? Yes. One assumes it's. I mean, that's what I thought. Why it didn't print correctly, I don't know. That's curious. 7 is A, ma'am. Seven is A. 8. 7 was given in the problem. 8 you have to actually calculate. 8 C. The formula, the N 1 minus P divided by the one on the formula sheet with proportions. Yeah, that's how she found number 9. I mean number 8. How do you do number 9? If it's true proportion, say words, Mackenzie, before I move on. It's the, because it's proportions, because of the P hat, I knew, yeah, it's square root of P, 1 minus P divided by N. I think I said it wrong. It's that one. Okay. Which she already did, apparently, because she's freaking on it. Number 9, if the true proportion is actually this. Here are the answers, by the way. I'll put those on the screen for her for a second. Let me look at it, Shalia. Shalia wants to know how to do 9.
What for the day of Luis becomes a verb?
That's a verb?
Yes. Like your name is symbolic of some sort of action.
I can't remember the name that Luis decides to put himself in the code, download himself into the internet.
You just check the.
And some dude decides to track him, and it makes him in terrible fashion.
Yes.
I uncode myself.
Instant uncode.
I would turn off the program. I started writing about one of me Alex. One kind of draft. It's pretty solid.
Wait, you wrote all the Illuminati?
No, but a fanfic about me
Did
and
you
Alex.
check
Oh god.
the N
No.
times P is greater than 10, and the N times 1 minus P is greater than or equal to 10? Because I'm thinking it fails.
Oh my
Good.
Luis.
I bet it fails, so normality's not bad. That's what it is really. It fails.
Collection is the only way you can do it.
Goodbye, dear. Freaking awesome job, Shalia.